And here we are, section 10.4. Title of the section is Find Probability of Disjoint or Overlapping Events. So we get some vocab, not a big deal, but maybe if I write it down. Compound event, the union or intersection of two events. And disjoint or mutually exclusive events. So two events that have no common outcome. This one is a nice example that the book uses, not in this worksheet, but in the textbook itself. Is if you're saying, hey, what's the probability of picking a jack out of the deck of cards, and then what's the probability of picking a heart, and realize that there would be an overlap, right? An intersection of the two events because there is a jack of hearts. So disjoint or mutually exclusive is like, what's the probability of getting a 4 or a 5? But if you do like jack and hearts, realize there's an overlap because the jack of hearts, and you can't count him twice because there's only one jack of hearts. So we've got two formulas that you really kind of have to know, and so no card would be good if you haven't started one already, but definitely get this on there. So if you have two events that are mutually exclusive, basically, this would be like, what's the probability of getting a 4, when you pick out of 52 cards, and if you were to pick a 5, and there are 4 5s out of 52. Sorry about the example 4, but there are 4 4s and there are 4 5s, so you would just add it up. This example here is the one where you say, hey, what's the probability of getting a jack? There are 4 jacks. Maybe I could write this one down here. Big arrow. So there are 4 jacks. And then what if I said, hey, and what's the probability of getting a heart? And you say, oh, well, there are 13 out of 52 hearts, and just add it up, right? I mean, here's the probability of getting a 4 or a 5. You'd say, hey, that's 8 out of 52. But if you added up 4 jacks and 13 hearts, realize that you've gone over by 1, because you have to consider that you've considered the jack twice. You considered him in this probability. Sorry, the jack of hearts you've considered twice. The jack here and all the hearts. So you have to subtract away when you have a jack and a heart. And that's what this piece is. This is that subtracting away the overlap. I hope that makes sense. So here, the first example is when you have disjoint events. So there's no overlap. So it's pretty straightforward. Hey, what's the probability? You roll a 6-sided cube, or die. What's the probability of rolling a 2 or a 5? Well, there's one way to get a 2 and one way to get a 5. So the probability is 1 out of 6 plus 1 out of 6. And that would be 2 6. Sorry, I'm skipping ahead. That's 1/3, or approximately 33.3%. I like percent. Right, so these are just disjoint events. You say, hey, what's probability? Again, or is always add, or you add up the possibilities. So here you can try one. What's the probability of rolling a 1 or an even number? See if you can't get that. And hopefully you got 2/3. So there is 1 out of 6 to get a 1, and an even number would be 3 out of 6. And there's no overlap, so I just get to add them up and get 4/6, which is 2/3, or 0.66, or even better, 66.7%. Nice. So now we start getting into the overlap, if you will, right? So here the example is you roll a 6-sided cube. What's the probability of rolling an odd or a number less than 3? So how many odd numbers are there? There are 3 possible outcomes for odds. And how many ways are there numbers less than 3? I believe there are 2 ways, right? 1 and 2. But because, right, at this point you've considered, maybe we should write them out. What is the probability of rolling an odd? 1, a 3, and a 5. And then here you go, what's the number less than 3? You'd say 1, if you can write it, 1, and 2. And so realize, like, if you were just to add up 3/6 plus 2/6, you should say, oh, wait a second, I've considered the 1, I've like double probabilityed it, but you can only get 1/1, right? There's only one way to get it, so you have to subtract the overlap, and that's what this formula is, right? And so here you should say that's 4/6. Sorry, I'm having a little hard time with my pen. 4/6, there you go, 2/3, or 66.7%. So does it make sense? So again, just you got to read carefully, and you got to look for this overlap, an odd number and a number less than, this 1 gets repeated, and you want to subtract it out. So here we go, example 3. It's a little bit more complicated just because it's a little more wordy, but we can still use the same formula. So here, in a survey of 300 students, 150 like pop music or country music. About half of them like pop or country. And then there are 97 students who like pop music, and there are 83 students who like country music. So we're trying to figure out the probability that a randomly selected student likes both pop and country music. So we use the same formula. Here we identify, right, that the kids who like pop music, so we just arbitrarily set A for pop music and B for country music. So for A, we've got 97 students out of a total of 300 who like pop. And we have 83 students out of a total of 300 that like country. And then we have 150 that like pop or country. And so using the formula, we're basically going to say P of A plus P of B, and then subtract away the P of A and B. And so realize we know this, we know this, we know this. We're trying to solve for this. So we would simply put in the numbers, 150 over 300, right? 97 over 300. Oh, my pen is terrible. Plus 83 over 300. And then we're trying to figure out this P. I'll just leave it as P. So it's just a simple equation here. It looks like we're going to add these two up, subtract 150, move the P over. You should solve and get 30 over 300, which is the same as 1/10, which is 10%. So again, nice example here where we're using the formula not to figure out the probability of A or B, but to figure out the probability of A and B. A student that likes both pop and country. Nice. So this is, again, we're back to the die problem. Two 6-sided dice. So again, it'd be nice if you could just take a second and come up with that matrix. So the possible totals, either snake eyes, 2, or double 6s, 12. And so you should say, well, yeah, I could get a 3, a 4, a 5, a 6, or a 7. And then you could also, if you had the first die come out as a 1 and the second as a 2, right, then you should be able to fill in the rest of this. And there you go. It's all filled in. I kind of took out the part for you to watch me do that. So again, this is a nice, should be a pretty easy thing for you to put on your note card, right? Just you got to be able to look at this and say, okay, I can figure out these are the possible totals. And again, from the classroom exercise, if 7 is the most likely total when you roll 2 6-sided die. And so now you get to do this. The probability, the sum is not 4. So realize how many 4s you have. You have 3, 1, 2, 3 4s. So you could count up all the others, or you get to do something that's pretty nice. You say, hey, 1 minus 3 out of 36, right? Because the total probability of rolling any of these totals is 1 or 100%, or 36 over 36. Again, nice technique here. This is then 33 over 36, which reduces to 11 over 12, which comes out to 91.7%. So again, nice technique, this 1 minus. And so here the sum greater than or equal to 3. And basically here, the only one that's left is a 1. So instead of counting up everything else, I mean, most of you would just say, oh, that's simple. That's 35 over 36. But realize you're in your head, you're saying, hey, the total is 1, and I'm subtracting the 1 that's not part of being greater than or equal to 3. So that comes to the next slide, which is this rule. So if this is called the complement, which I think you did in geometry as well, the complement angles. But basically, there's the probability of a event or the probability of not of a event, but they add up to 1. So if you want to figure out the probability of one thing, you can always subtract the opposite from 1, or 100%. So here are 3 problems. If you want to give them a go, I'll give you the answers. Go ahead and hit pause, and when you're ready, hit play, and the answers are coming. And here are your answers. So you roll a 6-sided cube. What is the probability of rolling a number less than 4, which would be the numbers 1, 2, and 3, or an even number, which would be 2, 4, and 6. And so you could make the mistake of saying, oh, 3 over 6 and 3 over 6, that would be a probability of 6 over 6. But realize you're repeating the 2, and therefore you have to subtract that out. So here you go in a survey of 125 people, 90 of them like orange juice or grape juice. And so you would say that's, in the formula, that's 90 over 125, which is equal to the probability of those who like just orange juice, 62 out of 125, plus the probability of just grape juice, 43 over 125. And that subtracts away the probability that you like both, right? That you're trying to figure out that they like both orange juice and grape juice. And grape juice. I'm just going to use O and G. And so that's your formula, and you should get 3/25. And then this one, subtract. I basically took 1. The total's not 8. There are 5 ways you can get 8 out of 36, so I use this formula. Hey, fantastic. We'll practice this all tomorrow in class, and see you then.